Hello everyone, my name is Alejandro Ojeda, and today I'm going to talk to you about Lab 4 for Physics 2212. The purpose of this lab is to predict the behavior of circuits containing resistors in series and parallel. Use multimeters to measure the actual values of conventional current and potential difference in the circuits and examine the behavior of ohmic resistors and capacitors. Use formula as a platform where the Ohm's law, which is voltage is equal to current times resistance, resistor series and parallel rule, where the resistors in series is equal to the sum of the resistors, while resistors in parallel be 1 over the resistance, the sum of them. Loop rule is that the sum of the voltage in the loop would equal 0. The capacitors, we also have the capacitor series and parallel rule, just in case. And the capacitance, which is charge divided by voltage, and we use Phys interact similar for materials. Also, just in case for points, system circuit surrounding is nothing. Now, the first circuit is that there's two 1.5 voltage batteries, two resistors, 147, the other 100 ohms, and 2 1 meters. So we get that since these resistors are in series, we get that the total resistance 147 ohms. The voltage in total is 3. Then we plug those in to find I. We get 0.0204 amps, and it's negative backwards. And the ammeters are the same current, have the same current. Now the change of voltage will equal 0 since it's the since both the batteries is being subtracted by the two resistors, and there's your answer. And as shown in the slide, it shows you the result of how much is each one of these voltage generated by each resistor. Now here's how it would look like as a graph. Um, at first, it goes a little down from C to D after being all the way to 3 volts, say around 2 volts now. And then after passing through the second resistor, it's basically 0 volts. Now, if the resistor with 100 ohms were to be parallel with the ammeter, the current will flow through the ammeter instead of the resistor, which will reduce the total resistance in the circuit. And because of that, in the simulation we can ignore the 100 ohms resistor and just use the one with 47 ohms, and that would change the current to 0.0638 amps. And by the way, since the voltage in the wire and the ammeter are 0, the resistance is 0. Now for the second circuit, we use 2 tries. We did 2 tries. The first try was with the 10 ohm light bulb, 9 ohm voltage battery, and a 0.2 F capacitor. While the second try, it was with a 20 ohm light bulb. In the first one, we saw that they both charge and discharge about the same time of 12 seconds. But in the second one, when we increased it to 20 amps, the time to charge and discharge took longer for about 8 more seconds. And the charge and discharge time was not as close as when it was 10 ohms. Now here's the time dependent voltage across the discharging capacitor R circuit. Here is data to calculate the voltage and the time. Then this was done with a 9 voltage battery, a 0.2 F capacitor, and a 30 ohm light bulb. Essentially, it took 7.07 seconds to discharge the capacitor. However, if it were true, it would have taken 6 seconds, as shown with the formula of 30 ohm times 0.2. Now, there might be some possible errors in this. Like, for example, I may have started earlier or ended it too late, the stopwatch, when getting the time for how long it took to discharge or charge. Now, for first what ifs, if we had connected an actual ammeter instead of a simulated one, some current would have actually gone through the resistor, since not all current goes only to the ammeter, since there's still some that goes to the resistor, which would have affected the outcome of the amount of current in the system. And in the second what if a real battery and capacitor were used, the capacitor would have still charged quickly, but still not instantly, because batteries have internal resistance, which was not accounted for in this lab. And finally, we know that to conclude, circuit currents will try to flow in paths with less resistance, otherwise, charging and discharging will take longer.